In this video, I'm going to try and teach you the basics of C# programming. This video will be divided into sections, so if there's one topic in particular that you're interested in, then I recommend looking in the description for the timestamps. Each section will be finished off with a challenge, and yeah, let's get into it. Let's create our first project. So you're going to go to the upper right corner, create a new project, and you're going to see a bunch of templates. What we're going to do is go to the search bar here, type C# console. I'm going to use the console app.net framework. Here you can name your project. I'm just going to name one Hello World. You can name yours whatever you want. Leave the rest as is, and then click create. So once you click create and wait for a few seconds, this is what you should be seeing. This is your integrated development environment, or IDE for short. So here, this part in the middle, you have your code editor. This is where we'll be writing all of our code today. On the right, you have your Solution Explorer. You might have something GitHub Copilot-like. You can just close that out and you will see the Solution Explorer. And here you can see your files. You have the program CS. And if you look here, this is actually also the file we're editing right now. And up here, you have this green shiny triangle button. This is the run button or the play button, what you might call it. So this is what we'll hit to run our program. So let's start writing some code. All of the projects we'll be creating today will utilize the console to display our output. So let's start by writing something out to the console. How you're going to do that is you're going to go in between these two brackets. So on this line in the middle. And we're going to type console.write line, open parentheses. As you can see, it automatically adds the closing parentheses. Then we're going to add quotation marks. Again, adds the open and closing automatically. And inside the quotation marks, we're going to write whatever we'd like to output to the console. I'm going to write hello world. And then I'm going to finish off with a semicolon. Now let's try to run a program. Let's go to start, press that. And as you can see, it outputs hello world to the console. Now let's go through this line to make sure you understand what's happening. You might have noticed that this line is color coded. So you have the console, that's in green, the right line in yellow, and what we're outputting to the console in orange, and the rest is white. And as you can see, we finished this off with semicolon. The reason we're doing this is to tell the program or the computer that we've completed the command. There's no more extra things coming after the semicolon. So if we leave the semicolon out, you can see there's also a red squiggly line. It says an error code and the colon to show that the semicolon is expected. So it's just how we finish every line in C#. It's actually color coded to help you when you're reading it differentiate what's a class, what's a method. I will cover all of these terms later. But for now, just remember that the console is a class. A class is like a box containing something, and that box contains methods. For instance, write line. Now you can see it says hello world here, just like we've written out here in our code editor. And now comes the time for your first challenge. So for your first challenge, I'd like you to change our program. So instead of hello world, it writes out hello and whatever your name is. I would recommend pausing this video and having a go at the challenge yourself. And in a second, I'll show you how to solve it. Yeah, so we'll start out by closing the console window. And actually all you need to do is, remember I told you can write whatever you want in here. So instead of hello, we'll leave that. And we'll just change this to, in my case, DevSpark. So if we run the program again, now it says hello DevSpark. So what we've done right now is actually create our first program. You've created a program which can output anything you want to the console, but it's hard-coded. What this means is that it's not dynamic at all. If you wanted to change the name, for instance, to show to someone else, you could change it to Peter, Jane, whatever you wanted. You'd have to go into the program and change it each time. It would be much cooler though if this was dynamic and no matter who tried this program, it would say their name. And that's where we'll introduce the second topic today, which is called variables. Well, what are variables? Variables are different types of data used in programming. And today I'll introduce to you the 4 variable types which are most commonly used in programming. And those 4 variables are the string, the integer, or int for short, the float, and lastly, the bool type variable. And just to let you guys know, if you want to, let's say, keep notes in your program to like write down as you're learning, you can use this double backslash, forward slash. I can't remember what it's called, but this way, I believe it's the forward slash. So you tap two of these, as you can see, it turns green, and then you can write whatever you want here, and it won't affect your program in any way. And it's the same if we have some code that we don't want to use right now. We can actually just place two forward slashes. Now this won't be read when we run the program. And you can just delete the forward slashes again, and then it will be read. So let's start off with what is a string? Well, the string is actually a piece of text. So, for instance, this is a string. It's inside quotation marks, and it's marked with orange. So if we wanted to create a variable of the type string, we would have to start by declaring which type of variable we'd like to create. And we'll do that just by typing out string. And now we need to, so now that we have the type of variable we'd like, we have to name this variable. We can name it whatever we want. This is a totally valid name, but not easy to read. And if you come back to this in 6 months, you will have no idea what this is about. So let's make this something that makes a bit more sense. Let's just type my name. So now we have the data type and we have the name of the data. Then we need to set whatever it is equal to. We'll do that by space and then an equal sign. And now we can create what the string should be. So I can say Spark and finish off the semicolon. You may have noticed there's a red squiggly line, and this is because it's currently not a string, because just like up here, a string needs to be inside quotation marks. So if you do it like this, now you've created a string. Now let's move on to the integer. As I said, integer, or int for short, is a whole number. So this can be like 1, 2, 3, 4, 5, as long as the number doesn't have any decimals. We get to that later. So if you wanted to declare an integer, you would type not integer, but just int, and then we would have to name the integer. So I will just say my number. Again, you can call this whatever you want. Set the equal sign, and then I can just say 1 or 2 or 3 or whatever. Let's just set this to 3 and then a semicolon. And as you can see, we don't need this to be in quotation marks because it's no longer a piece of text. As you may have noticed, there's a green squiggly line underneath our names. This is just because, as it says here, we have assigned it, we've created it basically, but it's never used. When we use it later, the green squiggly line will disappear. Now we're going to cover the float type. What is a float? Well, the float is a number with a decimal. So as I said before, integers, whole numbers, they can't have decimals, but floats can. So if we wanted to create a float, we'll type float. We will have to name it. Let's just call it my float or my decimal number. Use the equal sign and then 1.5. Notice that I use a dot and not a comma. I will use a dot for this. If you use a comma, you will get an error for this because it will separate the numbers more than treat it as just one number with a decimal. It will think it's two separate numbers. We'll get to that later as well. But just remember, use a dot. Now you can see if we use the semicolon, we'll get the red squiggly lines again. It's actually because right now it thinks it's a different kind of data type. So we need to specify to the computer that this is a float. So therefore, we'll after the 5, we'll type F. And as you can see, the red squiggly line disappears. Now the last variable for today is a bool. That's short for Boolean. Well, what is a bool? Bool is basically true or false. So it can't be data like a piece of text or number. It can only be true or false. Now the challenge for this part of the video is for you to create your own variable of the type bool. Again, I recommend having a go at this yourself. And in a second, I'll show you how to do this. Okay, so we will start by typing bool, like we did with the string, integer, float. And then we will have to name the bool. Let's just call it my bool. Then we have to set it equal to something. Can set it to 1, can set it to a piece of text. As I said, you can either set it to true or false. Let's just set this to true. Now that we've covered the types of variables, some of you may have noticed how we're actually writing the variable names. So we're writing it like, for instance, string, and then we're naming our variable. So we will call it my name. We can say my name and my last name. is equal to. So for this example, just read the text here. You can see it starts with a small letter, non-capitalized letter, and then we actually, for each new word in the name of the variable, we're capitalizing the name again. This is what is called camel casing. So the first letter of the first word is small, and then you capitalize the letter of the next new word. So if you were to create a string just called name, you would not capitalize anything at all. This is just the basic syntax of C Sharp. So yeah, now that we've covered the types of variables and the camel casing part, now let's get to the next part, actually using these variables and get these ugly green squiggly lines removed from our program. I am going to delete this. You can keep it, you can comment it out. I'll just delete this to make it easy for you to understand what's going on here. Yeah, so now let's try and use these data types, these variables, to make the console write something. So I am going to declare or create a new string. Let's just call it name. And I'm going to set it equal to def spark. And here's the next challenge. Instead of making our program write the whatever you typed here out to the console, I would like for you to change your program to write out whatever we've set our string variable to be. Again, I really recommend trying this out for yourself first and then watching my solution in a few seconds. So if we want to use the variable inside our console.writeLine, what we actually need to do is delete all of this in here. And instead, you just type name. So the name of our variable. And if we run this now, you can say it says DevSpark. If it changes to something like Peter, it says Peter instead. So now what we've achieved is actually using variables instead of writing and hard coding in directly what this needs to be. But right now we're actually still at the same spot we were before. Again, this is hard coded, so we need to change this each time we want something new outputted to the console. So what we're actually going to create now is more of a dynamic program. So what this small program here will do, I've created a small demo for you. It will say, hello, what is your name? And I can type in whatever I want here. I can type in DevSpark, for instance. And when I press enter, it will say, hello, DevSpark, and the program will end. So let's start off with a clean slate. The first thing we want to do is make the console ask for a name. And this is actually done using the command writeLine, which we used earlier. So console.writeLine, and open up parentheses. And here we can just say, hello, what is your name? So now if we run it, we actually have the first part of our program. Now what we need to create is our name. So we need to create the string variable. Let's call it name for now. And now instead of setting it directly equal to something we type, we want the console to read out what we type. So we'll be doing that by accessing the console once again. Before, to make it write something, we used writeLine. Now, as you can see on the screen here, it actually suggested itself. We will use the read line. And what this does is just that the console reads your input. So we open up parentheses, close it out again, and then a semicolon. We actually don't need anything inside the parentheses this time. So now we have the console asking for a name, and we've created the string variable called name, and we set this to whatever we type in our console program. So we can actually type now in our console. So the next step is making the console greet us. But if you'd like, you can pause the video here, try it for yourself. But for now, I will go ahead and show you how to create the rest of our program. So now we need the console to greet us again with our name. So we're actually going back to using the console.writeLine, and we're going to use the variable. Try to run our program, and it says, hello, what is your name? I can type DevSpark, and it will say DevSpark. Now, as you may have noticed, it just says DevSpark. It doesn't say hello, like the demo I showed you before does. That's because we need to use something called string concatenation. It sounds much more difficult than it is. What string concatenation basically is combining string variables with another string variable or another piece of text. So what we need to make the console, just instead of writing a name, we actually need to make it write hello. We're going to go outside the quotation marks, add a plus sign, and then we can use our variable. So now when we run our program, it says hello DevSpark, As you can see, there's still a small detail missing. Right now it says hello DevSpark with no spacing in between the words. This is because we've told it to say hello, and we've told it to say the name we've typed, but we haven't told it to leave spacing in here. And you can just fix this by adding a space after hello. So right now you have hello, space, and then the name. So let's try to run a program once again. Let's type whatever you want here. I'm going to type DevSpark again. And now it says hello DevSpark with proper spacing. And now comes the next challenge. So the challenge we're going to do is we're going to change our program. So instead of asking us for a name and then greeting us by our name, the console is going to ask us where we are from. So I'm going to type in the country I'm from. I'm from Denmark. And when I type that, it says, I have heard great things about people from Denmark. So that's your challenge. Have a go at it yourself. And in a second, I'll show you the solution. So this is the starting point. We have the program where it asks for your name and then greets you by your name. But what we can change this to is hello. And instead of what is your name, we can just type, where are you from? Then the string name doesn't really make sense anymore because we're not typing in a name. We're typing the name of a country, but we're typing which country we're from. And again, we can change this from name to country to use this variable instead, because now name no longer exists as we've changed it to country. And instead of hello, we can just say, I have heard great things about people from, remember the spacing here, and then the country. So when we run this program, hello, where we're from, I'm from Denmark. I have heard great things about people from Denmark. Now, just an extra side note on using variables in your programs. Before we use the console to read a piece of text, string variable, but let's say we wanted to create a program where the console asks for your age, then we have to use the int variable, so a whole number. So if we're going to create an int, let's call it age, and we're going to set it to console.readLine, just like we did before, right? Now you can see alarm bells going off. There's a red squiggly line, and it says that it cannot convert a string to an integer. That's because when the console tries to read something, it will always try to read it as a piece of text. So therefore, we need to convert a number into a piece of text. So instead of setting this variable equal to console.readLine, we will be setting equal to convert. This is a class, just like the console. So we'll use the dot to see the methods. We will type to int. You can use whichever of these, 16, 32, 64. We'll just be using the int 32. So we're converting it to an integer, and then we can open up parentheses, and in here we can type a console.readLine and add an extra set of parentheses, and then finish off with the semicolon. So yeah, just quick side note, if you want to use numbers, you have to convert them first if you're going to use the console read line. So now we can go ahead and type console.readLine, like your age is, maybe colon here, spacing, and then plus age. So let's just say we're 25, your age is 25. So yeah, just a small side note, if you want to use integers, remember to convert them. So now we have a program that can read our age, but for now, our program doesn't really go that far, so to speak. So it's how old are you? We'll type our age, and then the program's finished. It would be pretty cool if a program could branch out in different directions depending on what we give it. And this is where the next topic comes in, called conditions. Now, for clarity's sake, let's delete this again, just so you can see what's going on. What are conditions? Conditions is basically to check if something is, for instance, true or false, or to check a value of something we feed to the program. So you have three types of conditions. You have the if else, and finally we have the else. So to showcase conditions, I've created this program which acts as a ticket office. It will ask for your age, and depending on your age, it will give you a different ticket price. So it says, welcome to the ticket office. What is your age? If I type 5, you are a youth. Your price is $5. Now, should I type 80? Then it says you are a senior. Your price is $8. And should I type, for instance, 25? It says you are an adult. Your price is $10. So to create this program, we will need to start off by making the console ask for our age. So you can say with a red line, welcome to the ticket office. What is your age? As I've showed you earlier, you can create the int called age and set it to console read line does not work in this case. So we will firstly have to use the convert to integer 32 and then add the console dot read line. Remember again the extra parentheses. So now it asks us for age and we can input it. Well, now we have to use the if else, and else statements to make our program branch out in different directions depending on our input. So we create an if statement by typing if. You can see it pops up here. And if you look closely, it says note, tab twice to insert the if snippet. So it can actually create a kind of a template for us. If I press tab key twice, it will create this for me. So so it says if true, then do something in here. Instead of true, we want to check the age. So we're going to use the age variable and we're going to, let's start with the youth prices. So let's say if the age is less than 18, then we're going to have the console write out, you are a youth. Your ticket price is $5. So right now, let's try to run the program. If we're going to the ticket office, we say our age is 17, so less than 18. Then you are youth, your ticket price is $5. Now, what do you think will happen if we say something above 18? Then we can say we're 222 years old, nothing will happen. And that is because we have not set a condition for this happening. So just as we did with the if statement, we need to add these two statements as well. And I can actually see I've made a mistake here. It's not called if else, it's called else if. I'm sorry about that. So just like we did with the if, now we can add the else if statement. We're going to type else, then a spacing, and then add an if statement. Press the tab key twice. So now we have the else if. We can quickly just create the else template as well. Here we're just going to type else and then tab key twice again. So in here we want a, let's say we want adult prices here, and we'll want the senior prices here. So in here we need to set the age to something senior. Let's say that the age is larger than 65. And instead of writing it all over again, we can just copy this, paste it. And instead of you are youth, we can just write you are a senior. Ticket price is, let's say, $8. So now we have our if statement and an else if statement. The else is kind of like a default setting or a final go-to. So if none of these conditions are true, the if and the else ifs, then you need, and you can add as many else ifs as you want. You can have 100 of these. It's not good for performance. There's a better way to do this. I'll show you that in a future video. But for now, we can add 100 of these if we want to. And then the else statement is the final go-to. So if none of these conditions are true, then we'll just default to using this path. So here we can actually just copy this again. Let's change this to an adult. Your ticket price is $10. So now run the program. Let's say we're 5 years old. You're a youth. Your ticket price is $5. If we say we're 22, then our ticket price is $10. And if we type 222, you are a senior, your ticket price is $8. So now we have 3 different paths for our program. So I've got a new challenge for you. For this challenge, I would like you to change our program we've just created. So if you give a high enough age, for instance, something like above 2000 years old, let's just set the threshold there. Then it says you are too old to be here. Now, this is the most difficult challenge so far because I actually haven't taught you everything you need to complete this challenge. So don't be discouraged if this doesn't work for you. I'll show you the solution in a minute, but give it a really good go yourself and be back here to watch the solution in a bit. So to complete this challenge, we actually need to, as I told you, you're going to add as many else if statements as you want. So we need to create an extra condition. So what we're going to do is create a new else if statement. Let's say if the age is above, I believe we set the threshold at 2000. Then the console should write back to you that you are too old to be here. A lot of you might already have done this, and as you maybe have also found out, this will not work actually, because if we say the age is an humongous amount, then it will just say you are a senior, your ticket price is $8. Now, why is this? This is because that we set two conditions, which in our case, for what we've typed, are the same. So if it's above 65 and it's above 2000. So here you're typing your age, and then, as I said earlier, code is read from top to bottom. The computer will then read, okay, this true? No, it's not true. Well, then I move on. Is this true? Well, this is true. It's above 65. So this is true. I'll just output that. Therefore, for instance, if we change this to be at the top, the 2000 tag instead of the 65, and then try this again, then it will actually work. But again, our program is not really dynamic if we have to move the code around each time. And it makes sense from a reading perspective that the conditions are sort of in order. So 2000 coming before 65 doesn't really make sense either. So let's Control C a few times. This is because there's actually no limit on this check. And this is because we need something called an AND operator. And right now, we're only checking if the age is above 65, but we're not set a limit, so the age can be above 65 and then go infinitely. What we actually need to do is set a limit to this. So after the 65, we will use a AND operator. We'll do this by using this AND sign twice. And then we're going to put age again. And now the age needs to be less than, for instance, our threshold, 2000. So right now, we're actually saying if our age is more than 65 and it is less than 2000, then we can try to run a program again. Say we're above 2000 years old, you are too old to be here. But if we run a program and say we're 150 years old, should also be too old, but isn't in our case, then you are senior, ticket price is $8. This is why I told you this challenge is by far the most difficult one I've presented to you this far, because I actually haven't told you anything at all about the operators. To figure that out, that will require a bit of Googling for you. So that's actually all for this topic. Now we're moving on to the next topic called loops. So what are loops? Loops are used to repeat tasks instead of writing the same code multiple times. So let's say I wanted to write hello a bunch of times. What I can do is copy and paste this text over and over again, then run the program, and I have my desired action. It says hello a bunch of times. This is not really easy to read. If you had to do this 1,000 times, it can get really confusing to read. And actually, if you wanted to make sure that it did it 1,000 times, you would have to count the lines. So what can be used instead are loops. We have three types of loops. We have a for loop, we have a while loop, and finally we have the for each loop. Actually, it's spelled in one word, like for each, like that. Right now, we won't be covering the for each loop. We will use this at a later point. So for right now, we're sticking to the for and while loop. So the for loop is best used when we know how many times something should repeat. So to write a for loop, you write for, and then you can see, just as we did with the if statements, you can press the tab key twice, and then comes the template. I realized that this is much more confusing syntax than what you've seen so far, but let's go through it slowly, and I'm sure you'll learn it along the way. So let's say I wanted a program which could count to 10. Well, to do this, I will have to use the console write line, then just would have to write out I, then specify the length up here, and then run a program. And now I have 0 to 10. Now, why does this work? Let's go through the syntax so you can properly understand this. So let's just break the for loop down step by step. Firstly, we create an integer. We'll name it I, and we'll set this integer to 0. Then we check, is I less than the specified value, in our case 11. If that is the case, then we execute our code. In our case, we make the console write out the value of I. Then we add 1 to the value of I, and then we repeat. and at some point in our code, I will be equal to 11, therefore no longer less than 11. The code will stop repeating, stop looping, and it will move on. Well, why is I++? What does that mean? Well, plus plus is shorthand for add by 1. So if I wanted to say 1 plus 1, instead of saying that, I can just say 1 plus plus. That's the same thing in C#. Now, a challenge for you. I would like you to change this for loop, and instead of counting to 10, it should count to 100. So to change this, we actually only need to change one place. Instead of 11, we just need to change this to 101. If we run the program again, you can now see it counts from 0 to 100. Starting at 0 would normally not be where we started. So if you want to change this, you can just change the integer I to be equal to 1 instead of 0. So now it will start at 1 instead of 0. Now let's move on to the while loop. Just as the for loop is best used when we know how many times we want to repeat something, a while loop is best used when we don't know exactly how many times, but we know how long we want to repeat something. So let's say we wanted to repeat something as long as some certain kind of condition is true. Now let's start out by creating a condition. So a condition can be something which is, for instance, an age, or it can be something which is true or false. So we can, for instance, create a bool and set it, just call it my bool, and set it to true. Then, just as with the for loop, you can tap while, press the tab key twice. Now you have the template for the while loop, and then you can just specify the condition in here. So while my bool is true, you can see we get a green squiggly line here. And if we hover over it, it actually says, did you mean to use double equal sign instead of just a single equal sign? So I'll just comment this out to not get errors in the code. But one equal line is equal to assigning something, while, for instance, assigning a variable to be a certain value, while two equal lines is the same as checking for something. So instead of one equal sign here, we actually need to put two of these. As you can see, the squiggly line disappears. So while my bool is true, which it is, because we've set it to true when creating the variable, then we would like the console.writeLine to say hello. So let's try and run the program, and as you can see, it just says hello infinitely. It can be a bit difficult to see that something is actually happening here. So let's, instead of writing hello, let's just create an integer called I, that's 1, and then the console should write out I. And each time it has done that, it should add 1 to this value. So let's try this instead. And now, as you can see, it just keeps on counting until we stop the program. And the same if we set this to bool is instead of true being false, then it won't do anything because our bool is true, but we've checked if the bool is false. And if it is that, then it needs to start counting. So now I've learned how to use the for loop and the while loop. So now I have a small challenge for you. Instead of making it count upwards, try to make it count downwards using your while loop. Have a go at this yourself first, and then come back to the video to see my solution. So just like we're adding something, if we type plus plus, we can actually subtract from a number if we use minus minus. So all we need to do is actually, instead of typing plus plus here, we just need to type I minus minus. And then, of course, we need to set this as true as well. So if we do this now, then you can see it counts downwards. Now, as I mentioned earlier, there is a third type of loop called the for each loop. But before we dive into what a for each loop is and how it's used, we need to first talk about the next topic, collections. So for now, let's just delete all of this so we have the space to work. Now, what are collections and what are they used for? Well, let's say that we had a bunch of fruits just as the data type string. So we had a string apple, or just let's call it fruit 1. And we can have string fruit 2, which could be an orange. We can have string fruit 3, and so on. So let's say at some point we wanted to use this data and we had 100 different fruits. It would be much easier to categorize these in a collection. And there's two types of collections we're going to talk about today. There's more collections than these two, but the two most basic ones are arrays and lists. So just to sum up, collections store multiple values inside one variable. So let's start off with arrays. Well, arrays, they store a fixed number of values. So this is well used when you know that I want to have a collection of fruits and I need to have exactly 5 fruits, 8 fruits, 10 fruits, whatever. So to create a variable, we need to first specify the data type we would like in our collection. We would like a collection of strings. So we're going to type string just as we did before, but instead of naming our variable now, we're actually going to use these square brackets. So now this is designed for an array. So now we have a string array. So now we need to name a variable or our array. And instead of fruit, we're going to say fruits in plural. And now we can create this. So we're going to set it equal to, and then we're going to use these curly brackets. And in here, we can specify what needs to be in our array. So let's just say apple, and it needs to be string. So we need to use quotation marks. So let's say apple. Now that's the first entry in our array. We need to separate each entry, and we do this by using a comma. Then the second entry, banana, separated with another comma, and then use orange. So now we have an array of strings. We call it fruits, and this is where we specify array. We have 3 entries: apple, banana, and orange. The thing is about arrays that they are 0 indexed. What this means is normally you would say, well, what is the first index? It's apple, then banana the second, then the third being orange. So 1, 2, 3. But in collections, we start from 0. So this is index 0, 1, and 2. So instead of saying 1, 2, 3, you just say 0, 1, 2. And then we can actually print out the values of this array to the console. So let's use a console.writeLine. Just want to show real quick, actually. Instead of typing console.writeLine, because we're going to type this a lot, you can actually just type CW and then press the tab key. It'll do this for you. So now we would like to print out our array of groups. If we try this, run our program, you can say it just types system.stringArray. This is because it's trying to access our array and it knows it's an array of strings, but we need to specify which index we would actually like to print out. So we need to fruits. So actually after fruits, you need to add the square brackets once more, and then we can specify which index. So 1. Now, just before we run the program, have a quick think about what do you think this will print to the console? Will it be apple, banana, or orange, since we're taking index number 1? Well, as I said before, it is 0 indexed. So when we specify that we need to see the index 1, then it actually is banana. If we wanted to see the first index of our collection, we would have to type 0, and then we would get apple. So now let's say that you actually wanted to print out each part of your array. Then we would need 0, 1, 2, easy enough. Just say apple, banana, orange. But let's say you had a collection of 1,000 items, maybe 100 items, 50 items, whatever. Again, you had to type console.writeLine each time. And this is where our for each loop comes in. So instead, if we type for each, just like before with the loop, you can press the tab key twice. And now we have our syntax. Just like the for loop, this syntax can be a bit difficult, but we will walk through it now. Var is basically just a way of not specifying your variable. So instead of saying string, int, whatever, you just say var. So we know that we're going to print out strings, so we can replace var with string. Then item, in this case, this is the name, and as we've gone through already, you can name it whatever you want. So instead of item, let's write something that makes sense. We want to print out fruits. So let's say for each string object of fruit in collection. Well, what is the collection? That's our string array. What did we call our array? We called it fruits. So for each string item, again, we can use whatever name we want here. We just use fruit because that makes sense in our case. So for each fruit in a collection called fruits, we would like the console to write out whichever fruit we're currently looping through. Just remember, for each is a loop just like for and while. So we're looping through the array, and for each entry we find, we'll print out which entry we're currently at. So if we run this program, whoops, I forgot to remove these. So if we remove those, the previous console write lines we were using, if we print out this, it will say apple, banana, orange. And we can add as many entries as we want. So instead of adding a new console write line here, every time you needed to add something to your array, you can just add it to your array, and the for each loop will take that into account and print out everything that's in your array. Now for the next challenge, I would like you to create a new array. The array can contain any data type you'd like, but just to give you an idea for your challenge, you could, for instance, create a new array of cities, and then you have to use the for each loop to print out each city to the console. Give this a go, and I will see you back on the video when you're done. Now I'll show you my solution. Actually, we just need to change this to cities. And then we can, for instance, say Sydney, Copenhagen, London, and then for each would be more sense to to write city instead of fruit. Now you can see we have a red squiggly line on the fruits. That's because the collection fruits no longer exists. Now it's called cities. So we write this instead. There's no longer a variable called fruit because we've changed that to city. And if we try to run the program now, it prints out the cities. When we want to change the name of our collection, we have to change it twice. And it's the same case with our variables. We have to change that twice as well. A quicker way to do this, a shortcut really, is you can double click this to mark it. As you can see, it also marks all other occurrences. So you can right click the word, and you can use rename or the shortcut left control plus R. And this way we can actually rename it everywhere in the document instead of just going through them one by one. So that is actually all for arrays. Now let's move on to the next type of collection. We will continue with creating a list. Let's just stick to the same topic. Let's create something for strings and fruits. So we're going to create a list, then these angular brackets, and here you will specify the data type or the type of variable, so a string. And now we will get to name our list. Let's just call this group list equals a new list of strings. And then you have to finish with open close parentheses and a semicolon. And as we did with arrays, we added the entries to arrays up here when instantiating our array. We won't be doing that while instantiating the list here actually. We will be doing that afterwards. So we will type the name of our list, so fruit list. And then we'll type dot, because there's a bunch of extension methods. We'll type add, and then parentheses, and then we will type what to add. So let's just make 3 of these lines to get the same entries as we had on our array. Quick tip for you, if you copy or if you mark this whole line, then you can hold down left control and press D. This will duplicate the line. So actually you only have to change this instead of writing the line or copy pasting it over again. And then to write out each entry for our list, we actually do the same, which we did before. We'll use a for each loop. And here we can just say string, just like we did before. And fruits in. And now we need to specify the collection. Remember fruit list and not fruits. And you will get the array. To not get confused, you could call this fruit array. I'll just keep it at fruit for now. But for each fruit in fruit list. And then we will print out fruit. So that's just to specify or to separate these actually in the console. Let's just make a console write line up here. This is the array. And here with the list, this is the list. Now, if we run this, you can see this is the array, apple, banana, orange. And then we can see this is the list. So these are separated. And this is the point where you might think, well, why should you choose an array? Why should you choose a list? Because they seem very similar. The thing is, as I mentioned earlier, the array is a fixed size. So if you have a collection which you don't need to alter at runtime, which is meaning when the program is running, then it can, for performance wise, be a good idea to keep it as an array. But if you're going to add or remove something at runtime, the list is dynamic. It does not have a fixed size. So now I will just, to not confuse you when running our program, I will just mark all this. And then you can see this top icon in the toolbar coming out the selected lines. This will comment it out, so it won't be red. If you need to comment it back in, you can use the icon right next to it, which is called uncomment. There's also some keyboard shortcuts. I usually just use these. So now this won't run when we run a program. So this is the list. then it will show the list. And now we will add console route line saying adding to list. And then again, this is the new list. And I will try to add some more fruits. So let's just say cherry. Again, just duplicate this line. And we will try to run the program again. And as you can see, adding to the list, this is the new list. I forgot to print it out again. Sorry about that. So I will just copy this for each loop, bring it down here. Now just to walk through it real quick, send the list, create the list. We'll add 3 entries, apple, banana, orange, to our list. Then using the for each loop, just like we did with the array, we will print out each entry. Then just to show you guys, kind of separated, we're adding to the list. Then we add cherry and kiwi to the list, and then we print it out with a for each loop once again. So we run the program. You can see apple, banana, orange with the for each loop. Then comes the, not a new list actually, but an updated list or a list which has been added to. Then still apple, banana, orange, but now also with cherry and kiwi. So yeah, the key points being that arrays are fixed size, but lists are dynamic. You can add or remove items at any time. That's the main difference from arrays. Now let me quickly show you how to remove items. Let's just delete the part where we're adding. Let's add this, or let's change this to removing from. And now we're going to fruit list dot remove. And here we can specify exactly which string we want to remove. So let's just say banana. Now what this does, it will search the fruit list. It will look for an entry called banana like we have here. You have to make sure with strings especially it's spelled exactly the same. Accidentally add an extra letter or spell it wrong, then it won't find it. I will get an error. Then we can again just use the for each loop to print it out. So we have the first list, apple, banana, orange. Then we're removing from the list, and this is the new list, apple, orange. Banana has been removed. So for your next challenge, I would like you to create a new list. It can contain whatever you like. I've chosen to go with cities. So here you can see I've created a list. I have added 3 cities, Chicago, Amsterdam, and Tokyo. Then I've been adding to the list and the new list with added entries, same as before, Chicago, Amsterdam, Tokyo, but now also with Copenhagen and Berlin. Then I have been removing from the list, and the new final list with removed entries now only contains Copenhagen and Berlin. A small bonus challenge for you can be to find out how I've added the spacing in between these to make it more readable. Give it your best go and then return to the video to see my solution. We have first created our list, then we've presented it with a console route line. We're adding the 3 first entries, and then with a for each loop, we're looping through the list and printing out each entry. Then just with another console route line to just space it out with the adding ... And then adding Copenhagen and Berlin, presenting the new list, and then again a for each loop to print them out. Then we're noting to the user that now we're removing from the list, and then we're removing Tokyo, Chicago, and Amsterdam. And we're left with the final list only containing Copenhagen and Berlin. I asked you if you could figure out how we left spacing between. So when we ran a program, this needs spacing to separate our original list, our new list, and the final list. What you could do is actually just add another console route line and leave it empty like this with the quotation marks. That will also add a spacing. But what you can do instead, you can see here it's marked in yellow. It's the me again with the forward and backslashes. I will leave this as a backslash, and then n this will actually add a new line command. So you can leave as many of these as you like. You can see it's marked in yellow to confirm that this is actually working. So yeah, this you can leave as many spacings as you like. So at this point, we have a lot of code in our code editor right now from our list and our array. The thing is, it's kind of getting a bit messy now because there's so many lines of code and it's hard to keep a track of what actually does what. That's where we go into the next topic, methods. Now, what are methods? Well, in short, methods are a way of reusing code. So if you create a piece of code, you can reuse that by calling that method. Calling that method means to use it. So instead of using the method, we just say calling it. Now we have a few different things here. I'll go through this in a minute in the code editor, but first I'll go through it in this picture. First, we have to write what is a modifier, an access modifier. This just means who can access this code, who can use it from other places in our program. So if, for instance, in this case, it's public, it can also be private. It can also be other things, for instance, protected. Then you have the return type. You can see this is an int. It could also be a string. It could be a bool. Basically, what you get out of this method when the method is done. You can also create methods where you return nothing. If you wanted to return nothing from your method, but just do an action instead, then you would return void. Then you have your name of the method. They have chosen to call the method max. And why they call it max, I'll explain in a minute. Afterwards, you've named your access modifier, your return type, and the method name. Then you have your parameters in parentheses. This can be empty. In this example, it is not. In short, parameters are just what the method needs to function. So here they've created two parameters. They created one integer called x and another integer called y. And what they do in the method, they go inside these curly brackets, as this says body of the method, also called the method body. And this is where the action happens. So they've called it max because they want to find the largest number, so the max number. And here they create an if statement saying if x is larger than y, then return x, because then x is the largest number. Or return y, because if x is not the largest number, then y must be the largest number. Well, this method actually has the small mistake of if these numbers are equal to each other, then it will return y even though x is just as large. But let's try to see how we could do this in the code editor. So I have jumped back into Visual Studio, and as you can see, I've written a program here. I can just demonstrate it for you real quick. So what this program does is it says press enter to make me repeat myself. I press enter. Then it says you pressed enter. Press enter to make me repeat myself. And I press enter again, and it can go on like this for as many times as I've specified. A few more times, and then it stops. So you can see I've placed a console.read key. This just means before the program continues, just wait for the user to press a key. So I actually didn't have to press enter. I could have pressed any key. Then it writes, you pressed enter. And then it writes another line, press enter to make me repeat myself. And then another console read key. So 1, 2, 3, 4, 5 times I've actually written the exact same code. This could be done much quicker. So what I could have done instead is, let me just delete this. I could have created a method. So I could have used what is first the access modifier. So public, let's just use public for this one. And now I need a return type. This actually doesn't need to return anything. So this can just be void. Then I need a method name. Let's just call it press enter to repeat. Now we need open close parentheses afterwards. And then curly brackets. So now we've actually created the method, but it does nothing for now. Quick side note, earlier we talked about camel casing, where you start with the first letter of the first word being non-capitalized and then capitalizing the first letter of each new word. When you create methods, you use Pascal casing in C#. So press enter to repeat, all the words are capitalized. Now let's create the method. Well, what do we want the method to do? We need to go inside this method body, and then we can actually grab this, what we want the method to do. I will press Ctrl X to cut it out, and I will just paste it in here. So now each time we call this method, press enter to repeat, we make the console write, we press enter, then press enter to make me repeat myself, and wait for read key. So let's try to run the program. As you can see, if I press enter, the program finishes. That is because we haven't actually called a method. Again, called means using the method. So how do we call the method? Well, we actually just type the name of our method, press enter to repeat, and then we use open close parentheses, and then a semicolon. As you can see, we get an error. If we hover over this error, what we actually need is to change the access modifier. So you can see here in our main, this is where we run our program. You can actually see this is kind of a method. You have the access modifier. This is called static, then void, then main, and then you have your parameters. Well, we can't use public methods or private, for instance, in a static method. So what we need is actually to change the access modifier, and now the error disappears. Now, what is static? That is a access modifier I didn't mention when I talked about methods. Static is something that will never change. So for instance, you can actually also have static variables. So if I have a static integer, which is equal to 5, then during runtime, this won't be at some point equal to 7. Static is also an instance of a thing that you can reach from anywhere in your program. That's the short explanation of static. In future videos, if you'd wish, if you'd like, in future videos, we can go more in depth with static and what it means. But for now, let's try to call a method. Start the program, press enter to make me repeat myself. So if this works, we should get this when we press enter. You press enter to make me repeat myself. So now we have successfully created and used our first method. Now, before we get to the challenge for this topic, then I would like to challenge you for a bonus challenge. The bonus challenge is to change the program so the method is called multiple times. Have a go at this yourself and then return to the video. So what you could do to run this multiple times is actually fairly easy. You could just mark this line and duplicate it a bunch of times, run the program, and now you can press enter and you have the program. What you could do instead, which we've gone over earlier, is actually create a for loop. So if we delete these duplicates and then just insert this into the for loop, then here we can just specify how many times we want to call it. Let's just put 5, then run the program. And you can see this works exactly the same, but with the for loop, instead of doing this, we actually just need these 3 lines. Or 4 lines, sorry, with the brackets. If you want to save up even more space, what you could do is just create the for loop like this. This will work exactly the same. But at least for me, it's just nicer to read with spacing. Now let's, before we get into the challenge, create a new method. Because right now we're using it for something that wouldn't really make sense, just making a program which repeats itself. So instead, let's try to delete this program. Let's delete our method. And let's try to create a new method. So for the upcoming challenge, we will make a light version of a calculator, and I will just show you quickly how you would go about making a method for adding numbers together. So if I wanted to create a method for adding numbers together, I would create a static as the access modifier. Now void won't work because if we want to return something a calculator does, we would have to return a number. So in that case, what would we have to return? We would have to return an integer. Now, what should we call this method? Well, it adds numbers together. We can just call it add. And now, with the parentheses and the curly brackets, we have a method. Now you see this returns an error. This is because not all code paths return a value. And this is because we've specified that this method needs to return a number. So for now, it doesn't return anything. All we can do to just make the error go away is use the return keyword, return 5. This fixes the error, but now returns an integer. But this is not what we want to do. We don't want to return a specific number each time. We want to return 2 numbers added together. So which 2 numbers should we add together? Well, for this, we actually need to use the parameters we talked about before. Remember, if we go back to the picture, they used int x and int y. So let's try this int x. Then you have to separate each integer with a comma, int y. Again, x and y just basic namings in mathematics. You can call them whatever you want. You can call it first number, second number, so on. So what do we want to do? Well, we want to add these together. So this method should return the total value of x plus y. So we will use the return keyword again. Return x plus y. So now a method for adding numbers is actually complete. Now let's call the add method. There is an error. Now, what does the error say? There's no argument given that corresponds to the required parameter x of program.add, which takes. So this is a method, and it takes in parentheses 2 parameters, int and int. So we don't give arguments. Well, what are arguments? Arguments is when we call a method, and then the arguments we put in parentheses. What does it want? It wants 2 numbers, because we've specified in the parameters that we want this number, x, and this number, y. So 2 numbers. Let's just try with 2 numbers. So 1, remember again, we have to separate these numbers, and comma, and 5. Now the error disappeared. What will this return then? Well, if we run the program, it will return nothing. Why does it return nothing? Well, it actually returns nothing because we haven't asked it to write anything yet. So just a quick side note, if you want to test out your method before making it display in your console, you can actually do something which is called debugging. So debugging is a way of testing your program at specific points in the runtime. So if you go to the left side, this grayed out kind of line, you can see if I hover my mouse here, these white dots appear. This is actually indicating which line you want to place the debug. And where you would like to place the debug is usually just after which part you want to test. So I would like to test what does this actually return. Well, I would in that case place the debug right here, just underneath that line I want to test. So you can see now when I click the mouse, it becomes red, and the line which I test is also in red. Now I can start my program. Then it will run, and instantly when it gets to this line, it will go out. Then it will start to run, and then instantly when it gets to this line, which I want to debug, it exits out to the code editor while keeping the program running in the background. So you can see it's not fully stopped. I can stop it now, or I can continue the program. So you can see it's at this line, and it uses the add method, it's marked that itself, and then it returns 6. It even says if you hover over it that the add method will return 6. Now we want to actually write it out to the console. You can do one of two things. The first thing you could do is instead of using just add, you could say console.writeLine, then in the parentheses, then you can use add, then another set of parentheses, and here you can add your numbers together. So you get this nice, not confusing at all, double parentheses. And if we run this program, it returns 6. And if we change this, let's say 22 plus 155, it says 177. So yeah, this is one way of doing it. What you could do instead is create actually a new integer called result. And what is result equal to? Well, result is equal to these numbers added together. So we could write integer result equals add. And again, we can just use the same numbers, 155, 22, then a semicolon. And instead of writing the method inside the console write line, you could just write result. And this will also write the result out to the console. So now for your challenge, it's just to create a basic version of calculator. We already have our add method. So now I would like you to create 3 new methods, one for subtraction, one for division, and one for multiplying. Give this a go and then come back to the video to see how I did it. So for creating the other methods, let's just, for starters, delete this, not to confuse yourselves too much. By the way, just a quick side note again, if you can see these, like the boldness of these words are just the same as up here. But if we delete the call of the method, then it kind of gets grayed out. And you can also see that here it says 1 reference. If I remove the call, then it says 0 references. So you now know when a method is kind of grayed out, it's because it isn't actually used. Let's continue with creating the other methods. So let's start with subtraction. We could create another method, static int subtraction. And then again, we can just use int x, int y. Then after parentheses, just use curly brackets. Then we can just return x, and instead of plus, then minus y. So this is actually the whole method for subtracting. You might be wondering, will it be confusing at some point that we use int x and y both here and here? Now, when you have two curly brackets like these two, for instance, if I click this curly bracket, then this one is marked. If I click this one, then this one is marked. It marks the partner curly bracket. So this is the opening curly bracket and this is the closing one. So between the opening and the closing one, this is called a scope. So this int x and y and the result, what we return, only exists inside this specific scope. So even though this is called int x and this is called x, and both of these are called y, these values won't interfere with each other, even though it looks kind of the same. If you're really confused by it at some point, and just for your own sakes, you could call it something like int for adding, or int for subtraction in this case, actually, just to specify the names even more. But just so you know, this won't interfere with the program. So let's continue with the division method. Again, static int divide, or division. Let's just call it division. Well, I wonder what parameters we're going to use. Well, again, int x, int y. And then open curly brackets, return x divided by y. So now for the last method, we're going to create static int, then multiply. Then again, int x, comma, int y, open curly brackets, return x, and then use this asterisk, the star sign. So x times y. So just to show the program, I'll quickly write a few console write lines. So now if we run the program, I'll just use in 5 and 5 for x and y for all of the methods. We add some numbers. 5 plus 5, that's 10, checks out. Subtract numbers. 5 minus 5, that's 0. Now we're dividing numbers. 5 by 5, that's 1. And if we multiply 5 by 5, then it's 25. So now hopefully you understand variables, conditions, loops, collections, and methods. From here, learning more advanced topics than this becomes much easier because everything builds on these basics that we've gone through in this video. I hope this helped you out. If you have any questions, don't hesitate to leave those down in the comments. I will try to get back to you as quickly as I can. And I want to thank you very much for giving me your time. Thank you.